Hey everyone, my name is Rajesh Sampathkumar. I'm the creator of the Praval Agentic AI Framework and the application that you see here, which is Praval Deep Research. Praval Deep Research is an exciting AI powered application. It's a research assistant for academic papers. And equally, this could be used for any PDF style document that you might have in your organization to manage your knowledge base, to look at different kinds of insights coming from those research papers or technical reports that you might have. And then going one step further from there, getting insights about exactly what is in these papers. It has a lot of nifty features. In this video, I'm going to go through the features of Praval Deep Research at a very high level. There's a separate video that I've done which covers all of these features. And that's a user video. That's for those who just want to use Praval Deep Research. But this one is much more focused on how does the developer dig into the code base and make tweaks, create a new build for yourself. It's an open source project, so you really can do a lot of stuff with it. So I'll just spend a few minutes on Praval Deep Research and what it's all about, and then we'll go from there into the code base. Praval Deep Research is an AI-powered research assistant, as I said, and this is meant for academic papers. It's meant for archive papers of different kinds, and really the genesis of this idea was my own experiences in gathering different kinds of technical papers and machine learning and AI-centric technical papers and trying to read them to understand if some of them are worth my time, if it's something that I should skip in favor of reading something else. It's also about figuring out which papers are related to which other papers. There's knowledge tree that you inevitably create as you go through and read a paper and look at the references or citations and then read some of those. And the other part of this is keeping track with the fast changing world of AI and research in general more broadly, where there's an overload of information that the researcher tends to face. And how does the researcher actually get past this overload of information and start making sense of the knowledge base that they have and start having actually tangible, useful ideas for them to work on, or even tangible or useful ideas related to the topics in question that they can explore, right? So these are the sorts of questions that Praval Deep Research is meant to answer. So you can see that there's three different feature sets, if you will, three different ways in which you can use the application. So one of them is called Discover. So I'm going to go into that first. So this is where you can search arXiv directly from the search bar here. And then you can populate, you can index different kinds of papers. So for example, I'm going to look for tabular foundation models, and it's likely that I might get a number of results back. Probably I'm interested in this one, and you can see that I can select that particular paper that has come up from arXiv from the search, and then I can index that paper. Indexing that paper will, number one, store the paper into the database, and number two, it will produce a set of embeddings that we can use to look up answers to specific questions that the user might have. And I'll come to how this retrieval is useful. So let's say we index this. There's a feature out here that allows you to index and store this paper. And then you can run the same search in your knowledge base, and you can see if there are papers related to this topic. As you can see, I've done a little bit of searching around on tabular foundation models, and so there's all these papers out here that are related to that. This has VAJRA search integrated into it, so you can see semantic and keyword searches, and you can really move the slider in between the pure BM25 exact term matching and the pure conceptual similarity of vector search modalities. And VAJRA search is an extremely fast API. I'll talk about that in a separate video. There's a chat feature that allows you to explore a particular paper or a particular concept. So let's say that I've ingested a bunch of papers on a certain topic. You can see here that I've asked a question, and this is in the chat. I can just create a new chat here. I can ask a question, and then it responds in a specific manner. And I can ask follow-up questions as well. Moving on, there's a knowledge base that you can maintain within Praval Deep Research. As I said, that's one of the key things that you might want any researcher to benefit from, the ability to maintain their own knowledge base. And as you can see here, there's ways to import papers into this knowledge base, and everything that you indexed upfront on the Discover page that you saw me index, all that stuff turns up here. You can see that there's a title, there's authors, there's other kinds of details here. You can view the PDF if you want, and that PDF will open up on the screen. And you can look at the archive, you can look at the archive page and so on. So there's a lot of stuff that you can do directly within this knowledge base feature. There's also ways to import files and folders which are more sophisticated. You can drag and drop PDF files, you can add a folder, and you can also paste a series of archive links which will all get pre-flight checked and then uploaded into your knowledge base. So all of this is built in, and there's an interesting feature that I'm still building. This is not complete yet, or I should say it's in progress. There's a concept graph that Praval Deep Research can create for you, and this is based on all of the papers that you index. There's a lot of interesting stuff that you can find just by looking at what papers are there and how the concepts between multiple papers are connected to one another. So there's a paper here about ASICs for cryptocurrency mining. You can see that there's a number of concepts, and those concepts in turn are related to other concepts. And basically, right now, this is still a work in progress. So you'll see that the concept resolution is still a little basic and needs a bit of work to ensure that everything works out okay. But generally speaking, this I feel is a powerful way to visualize your knowledge. And I think that this kind of knowledge graph is here to stay, and a lot of people are going to be interested in it. So this is about concept graphs, and then I'll move on to settings. In settings, you can see that you can choose the LLM of your choice. It could be OpenAI or Anthropic or any of the others, and you can also choose Olama. And there's API keys. You can provide your OpenAI API key here. You can provide Gemini for structured extraction, and then embeddings that on OpenAI embeddings, you can basically run the entire application for the semantic search and pieces like that. And of course, you have the light mode and dark mode switcher. So these are all the features of Praval Deep Research. Now I'm going to spend the bulk of the time in this video just going over the code base. So I'll switch to the repository where Praval Deep Research's code base is. And I've just cloned it out here to my local machine, and you can see that I've opened it up in an editor. And I'm going to go over mainly the agents first. That's the starting point for our conversation here, because there's a number of different agents that Praval Deep Research uses to ensure that its functionality and capabilities are all agentic and they can be run using different kinds of features of Praval. Praval as a framework is actually pretty sophisticated in that agent to agent conversation is a first class consideration. We ensure that agent to agent communication is something that it's right out of the box. It's something that you don't have to engineer or you don't have to put together as an afterthought. The actual agent itself is set up using a decorator. So you can see that here there's a research planner agent that is set up as a decorator, and there's just a Python function underneath that, which allows you to do all of the agentic flow that you want to do. Agents communicate with each other via the reef, which is an abstraction in Praval, which allows you to send and receive messages. So it's only when an agent needs to respond to a particular kind of what we call a spore, a particular kind of message, that it actually activates the logic of the agent. Right? So you can see that there's the abstraction called spore that's used here. And there's channels on which you can broadcast. Reef is an abstraction that allows for multiple channels, and you can logically separate different portions of your application that way. So these are some basic things about Praval, and of course there's a series of videos actually on the Praval framework and how do you build with Praval. And I'll put a link in the description to that list of videos. There's a playlist as well on the Praval-AI channel. But then staying on Praval Deep Research specifically, this is the primary Python file in which all of the agents are defined. I'm going to go over some of this. So you have your key imports here, and from Praval you're going to import the spore, which is the knowledge carrying message that flows through the reef abstraction that I mentioned earlier. And then you're going to be able to import the agent, and this is a decorator, and this decorator allows you to wrap any Python function that receives a spore and outputs a spore and make that an agent. So that would respond then to any message that's received on the reef. The broadcast function allows you to, within an agent, it allows you to broadcast the results that you've computed as part of your agent's workflow. There is a chat function that's also within Praval, which natively provides every agent the capability to call an LLM. And the LLM configuration is not explicitly defined here. There's a configuration file that allows you to manage all that. And that's the beauty of Praval. It really takes away the complexity of defining an agent from the user. And even if you're using a coding tool like OpenAI's Codex, or if you're using Cloud Code, the API is structured in such a way that the abstractions are neatly defined, and that allows you to really define your custom skill, if you like, on how to use Praval, or you can define a cursor rules file or a agents.md or cloud.md. In fact, I have all of those different ways of managing my Praval coding agents, right? So in a nutshell, I have all of these key imports from Praval. And if I were to go into how each agent is defined, I have the decorator out here, which is in this case the research planner. And then the actual logic underneath that is then defined, right? That the chat function is called here, and then there's a prompt that's attached to that. And there's a user query that we receive as part of the spore. You can see that the query is defined as spore.knowledge.get query, and then that query is then attached to the chat, and the research planning agent really picks up on that. And then there's also the memory feature. You can see that there's memory equal to true, which is another nifty feature of Praval, where memory is natively enabled through just the decorator itself, and you don't have to really do double takes on how do I manage memory within Praval. You can just say memory equals true, and then you have different kinds of memory that you can unlock. There's a short-term memory, there's episodic memory, there's long-term memory, and there's a whole Praval video that discusses how to use these memory features. And as I said earlier, I will provide a link to that in the description. So you can see here that the Praval agent called Planner Agent is made to remember the query plan, and then there's a certain importance score associated with that. And then we broadcast the analysis request that we get here. So the research planner basically broadcasts an analysis request, and there's a research analyst that responds to this analysis request. So this is a pattern that I want to highlight to you, which is that you have specific spore types that you use to initiate certain kinds of workflows within your agent. So this creates a sense of single responsibility, and it also separates out the contexts of multiple agents. Each agent is meant to do one thing and one thing only. And you can see that the agent definition here is quite concise. It's meant to do just that one activity. And of course, it calls an LLM because it has to, because the agentic flow that you have here is there for a reason, because it's there for the reason that you want to use the LLM to take some data and do something to it and arrive at some result. And having said that, each agent is meant to do one specific thing. You can see that here the research agent picks up a research analysis request, and then it is able to then prepare report request, right? Kind of a response. And the report request response is an input to the report writer. So this is the agent that writes the report. It comprises of the executive summary, the key insights, and the actionable next steps in terms of what the report might comprise of. And there's a QA agent for question answering, and this QA agent responds to a QA request. You can see that there's within a session ID, you can get a question, and within a particular session, you can get a question. And the session ID is important because every one of the chat windows that you have there, it amounts to a particular session. And the question that you have is what the user is going to supply as part of the spore. Every time I send a message on the chat, that gets sent as a spore, and then the question is then uncovered from the spore. The conversation context is then obtained based on what is there in the spore. And this is also important because every time you construct a question in the context of a chat, the prior context of the historical conversation messages back and forth, that's really important, because if you look at any LLM based chatbot, that's how it functions. It takes all the prior context. It might take memory from what it has understood about you that has been stored as vectors or whatever, and then uses all of that to synthesize a response for you. So in a way that is not too dissimilar to that, we have a conversation context extracted from here. The spore really has all of that knowledge. And then you have the sources that are used as the references in order to provide your response. And all that is really part of the spore. And really, some of that heavy lifting is done here, is done in the analysis. You're a technical analyst, you use the plan below and provide a structured analysis with core ideas, risks, and assumptions, and practical recommendations. And then you get a plan from there and you use that plan as part of your report request. And the conversation agent really picks up from there, right? So this is what writes the response that you see here. So hang on, so if you see the chat, if you see any chat, you'll see that there's a certain structure to this. There's a direct answer, there's evidence from indexed papers, there's technical details, there's limitations on open questions, and then all of the sources, right? And this is important because you can see that that same structure has been maintained. That same structure has been maintained in the Q&A agent, right? So you see here that, okay, so you're a research evidence extraction assistant, extract the technical evidence from the provided source, excepts for the user question, do not invent claims or citations. And you can see other such details are present in the prompt here. And so there's different prompts here that are associated with different conversational or other kinds of follow-up questions. And you can see that here the rigorous research Q&A agent is then used. Direct answer evidence from the indexed papers, technical details, and limitations and open questions. So this is the portion where in this extensive prompt we have all of the details that the Q&A agent is going to use. And this extensive result is then broadcasted when the QA question answering is complete. And there's a session ID, of course. There's the question that we have, and then there's the result. There's the answer, as you can see here, and this JSON. There's the answer that has been provided as well, right? And then there's exception handling and so on and so forth. Now, we've seen that in the Praval Deep Research application, there's actually a graph builder. So I'll just go back to that for a second, just in case you missed that. There's a concept graph here, and then I'm trying to visualize this. So you obviously need nodes and edges, and you need a way of representing them. And what this graph builder is doing is really taking all of the papers and the concepts within those papers, and then representing them in a form that is suitable for rendering them as a knowledge graph. So you see here that there's an extensive prompt here. We do the usual stuff like extracting details from the spore for the graph build request. And then we go from there to picking out different JSON concepts and paper links, basically nodes and edges, that follow some of these rules. And it's by tweaking these rules that we can get better and better results. And as I said earlier, there's a bit of work that needs to be done in terms of bringing this concept graph up to scratch. And that's something that I hope that in the open source community that I can get some support from. Moving on, you can see that the candidate papers, the JSON construction, and the sending of this, all that is done here. And then there's a content generation agent, which allows us to handle the content generation workflow within the chat. Going back to the chat, you can see that there's a way to share your findings or your discussion that you've had with this application regarding this paper in the form of a tweet or a Twitter thread or as a blog post, as a markdown blog post. So coming back to the code, that's what this looks like, right? So this is the content generator agent, and this returns a JSON which matches all of these kinds of different pieces. You can see that there's a target format, which could be a Twitter thread or a blog post. And then there's a style, which could be academic, casual, or narrative, other kinds of details that are present there. You can see how this has been set up. There's a set of rules that are associated with this, and there's output schemas. And for Twitter and for the blog, there's obviously different styles that we require. So all of those have been outlined here. So many tweets, max tweets in the thread, and so forth. And once everything is done, again, we put together all of this and then send the result. The content generator then sends the result, right? So there's a broadcast here. You can see that there's a broadcast that happens here. You can see that there's another agent called the paper intake agent. And this is every time we want to extract metadata from papers that we are ingesting into the application. And there's a local PDF path hint that's provided. And we are asking you to return a strict JSON. And again, we provide a set of rules here in terms of what detail should be extracted. So you have the title, the authors, the abstract, categories, the date on which the paper has been published, the arXiv ID, and this is required in order to construct the URL so that we can redirect to arXiv from our application, right? So there's all of these details that we are extracting from the paper, and there's a separate intake request that this agent responds to. And then we return that JSON at the end of this. So we also use memory in case we need to do that. So there's memory that is used here just so that we know which papers we have ingested, and then there's in the short term, and then we have paper intake being complete. So you can see that there's some memory and context engineering being used here, and that could be helpful in case we want to build other features on top of recent papers and so on and so forth. There are a couple of functions here that I want to touch upon. So there's this function called ensure agents started. It doesn't return anything. It actually initiates the reef, which is our channel through which all communication between agents happens. It creates a channel called the broadcast channel, and it starts agents, right? It starts different kinds of agents. These are the planner agent, the analyst, the writer, QA agent, etc. And then there's a run research function that allows you to ensure that all of the research requests are acknowledged and you broadcast them. So this is what you use it for. And then there's a run QA, which again is in the context of the question and answering. So there's different functions here for building the graph, for running the paper intake, for running the content generation, and so on. And so there's all these different pieces that we're using for conversation title as well. So in fact, if I were to, you can run this function when you want to construct a title in your front end for a particular research chat. So this is what the structure of the agents.py looks like right now. And there's a lot more work to be done. I think potentially this can be expanded to a much more full-fledged application, but you can see that this is able to accomplish a lot for the sort of use case that we have. I think by tweaking the prompts and by improving some of the flows, we could get a lot more done. This has been built as a desktop app using Electron. So there's all the Electron assets here. There's a set of documentation here. There's a front end here that uses JavaScript and what have you. And there's also some scripts that allow you to, so there's these regression pipelines and there's a build script for building your Electron application. So that's in a nutshell the code base for Praval Deep Research. I hope you found this helpful to understand what the Praval Deep Research application is all about and how it can be used for different kinds of academic AI-powered research assistant kind of use cases. And as I've said in the other video, this is not limited just to arXiv, but you can really customize this to make it work for any kind of knowledge base that has PDF files that are generated as a result of some workflow. So it's really exciting that we can pull off this kind of capability with agents and the current state of LLMs. And I think Praval is exciting for that reason. So if you want to know more about Praval, you can visit the Praval website. I'll spend a minute on that. So this is the Praval website. And really, this is all about building simple agents that self-organize so that you can build complex AI systems. And there's a latest release 0.7.22. And this requires Python 3.9 plus, but yeah, I would recommend using the latest version of Python. And there's an extensive set of documentation here that discusses a lot of stuff around the decorator API, comprehensive memory, and stuff like that. And if you're working with an agent, all you need to do is point the agent to this page, and it should be able to parse it and figure out how Praval works and help you build with it. There's different features here. There's a decorator API. There's a self-organizing nature of the framework. As I've said, there's memory, and you've seen earlier in this discussion how we've used an extremely simple interface to build multi-layered memory, right? It's enterprise ready, so there's a number of multi-protocol messaging features that are within Reef, and that makes it secure. And it also has multi-LLM support. I've initially talked about this in the context of the OpenAI, Anthropic, Cohere, and other kinds of LLMs that you support. There's also tool decorators that enable API integrations. There's Docker deployment, and there's Reef communication that you can do with the likes of RabbitMQ. So you can actually just use RabbitMQ as a backend for Reef, which is really cool. It actually provides support for multiple file systems, S3, Redis, and Qdrant as a vector store. You can also do searches with VAJRA SEARCH. That's also integrated into Praval. There's a lot of stuff that Praval can do, and it's maturing really well as a multi-agent AI framework. I urge you to check it out and give me feedback. And I hope you found this discussion helpful, and that you'll build something exciting with Praval and Praval Deep Research really soon. Thank you so much. Bye.